time I need to be a bit more careful, draw my graph so it actually has multiple components. 5, 4, 6. Okay, so let's have a graph with 2 components. And we can see visually there are 2 components. There is a ocean between these islands. Okay, so and the challenge here is we want to be able to write an algorithm that will actually tell us this answer. Okay, this is a very simple graph. We can actually just look at it visually, but if you had millions of vertices and millions of edges, you might want an algorithm to solve that for you. To kind of map out, we need to have our, Boolean. Let's try writing that again. Pretty bad day when you misspell Boolean. Okay, and we want to have our visited. I'm not going to bother creating it, you can imagine. And then we're going to want to have the number of components. Okay, so we are going to have a count of components. The trick here is we want to be able to start anywhere in the graph and then make a traversal in this component and then have it complete and be aware that we still haven't visited everything. Now, we already have a solution to tell us we haven't visited everything because we have an array that solves that for us. Remember, as we traverse, we will have a array 1, 2, 3, 4, 5, 6. Which will tell us that we haven't visited anything at all. Okay, so we have that. So one of the kind of leaps we make here is, well, this is going to represent what we have seen so far. So what we need to do is iterate through this, start at the beginning and start looking for components and then mark these as visited. Okay, we already know how to do depth first search, that's fine. But what we need to do is actually iterate through this memory. Okay, so basically for each vertex in visited, then we need to say, well, if it has not been visited, there. Then what we can do is make a depth first search on that vertex. Okay. Crucially, once this traversal completes, then we know we have discovered a component, so we can add a count. So we can just simply say, well, components plus. Okay. Now that might seem a bit magical, but let's try to traverse through. If we start at 0, using depth first search, then we mark that as true. Okay, then we can go either way, it doesn't really matter. So let's go to 2, mark it as true. And then we see we have already visited 0, so we only have 3 as a neighbor to not visit. So go to 3, mark that as true. 3 only has 2 and 1 as neighbors, so it goes to 1. Mark that as true. Okay, at this point in time in the depth first search traversal, we have nowhere else to visit. Okay, so this recursive call will collapse 3 to 0. We get back here. So once this completes, then we say, okay, well, actually, we've found one component. However, the for loop, remember, it started at 0. So for v in visited, if it's not been visited, okay, but then we started here with that for loop. So now v will go to 1. We'll ask if not visited. Okay, it has been visited, so we skip. For loop moves on to 2. It's also been visited. Moves on to 3. It's also been visited. We finally get to 4, and this has not been visited. Okay, so now we actually make a second depth first search call starting here. Search of 4. I should say that's the first search of 0. Okay, so this is now going to be a second independent recursive call. Okay, and again, it doesn't really matter which way we go. 4 has 2 neighbors, 5 and 6. Neither have been visited, so just pick one. We go to 5, we have 4, which we have now seen. So we pick 6. Okay, that's now true. We're at 6, and that's now true. Okay, this call, there's nowhere else to go. So this one completes as well for a second time. And now we have 2 being the answer, the number of components. Okay, so here the thing to take away is we're using a depth-first search, like a sort of helper function here to navigate through or traverse through all of the vertices. Okay, but we're trying to solve the problem as well. How many components are there in this particular graph? Okay, so we iterate through what we've visited so far, and then once this recursive call ends the first time, we know, okay, this is the first component. Okay, are there any vertices remembering? Well, then we start again here. This is when the second depth-first search call starts, which it also completes, and then we detect this is the second component. The for loop finally ends when there's no more vertices to visit, and it returns the answer. Okay, maybe I should have this actually return the components. That's kind of important to actually return the answer. Okay,